Today we're going to look at evaluating trig limits. And as we look back at the previous lesson, you saw that our goal when we were doing our limit evaluation was to just directly substitute. If we directly substituted in and we got an answer, that was our limit. If we got 0, that was our limit. If we got a number over 0, we were undefined. And then the ugly situation was 0 over 0, which meant we had to do more work. With trig, there's only two things we need to look at. The first is we are going to substitute. Substitute and specifically also other trig identities. So we could be talking about substituting the value we're approaching right away, or we could be substituting in other trig identities, like sine squared plus cosine squared equals 1. And then the other thing is you're going to have special trig limits. And there's two special trig limits you want to have memorized. The first is the limit as x approaches 0 of the sine of x over x. If I were to substitute in a 0 right there, I get sine of 0 over 0, which is do more work. But you don't know how to simplify that with do more work. So one of the things that we're going to learn for now is that just simplifies down to 1. So if you can somehow simplify your expression to be the limit as x approaches 0 of the sine of x over x, you can substitute in a 1. The other situation is the limit as x approaches 0 of 1 minus the cosine of x over x. Once again, if you were to plug in a 0 there, the cosine of 0 is 1, so you get 1 minus 1 over 0, which is 0 over 0. This is once again an indeterminate form that's going to equal 0. And next year when you take AP Calc, if you go the route of AP Calc, you prove why those are the case. But for right now, it's just going to be a memorization piece we've got as we look at simplifying our trig expressions. So let's head down to the second page. And we're going to move down to these trig expressions here. Now, the first one right here is the sine of x over 4x. That is really close to a trig expression that we had before if that 4 weren't there. And we can actually do a little bit of manipulation. The limit as x approaches 0 of 1/4 times the sine of x over x. Now what we're able to do is 1/4 is a constant. And just like we can pull constants out of a distribution problem or parentheses, we can do the same thing with limits. So we can put the 1/4 in front, and then the limit as x approaches 0 of the sine of x over x. And as we said on the previous page, if we go to our little thought bubble up here, the limit as x approaches 0 of the sine of x over x is going to equal 1. So this whole expression right here, we can just substitute with a 1. So 1/4 times 1, which is 1/4. So if I were to look at a graph or a table, I would see that as I approach 0 from the left, and as I approach 0 from the right, I'm going to get closer and closer to 1/4. The other example here is the limit as theta approaches 0 of 7 times the quantity 1 minus cosine of theta over theta. Once again, I've got a constant there of 7. I'm going to pull that constant out in front. And then I'm left with the limit as theta approaches 0 of 1 minus the cosine of theta over theta. And what we said on the previous page is this is one of our special trig functions, which equals 0. So this ends up being 7 times 0, which is 0. So once again, if you created a table and you put in numbers on the left getting really close to 0, and then numbers from the right getting really close to 0, you would see that we would approach 0.